I'm Gene Eltonen, the Influx Chief Technology Officer. I'm here today with Mike Ortolano, the Chief Technology Officer of Absolute Haitian and co-owner. So welcome, Mike.
Thank you, Gene. It's a pleasure to be here. It's always fun to come to Influx and watch plastic parts being made on a molding machine.
Outstanding. So you know, we're here today, Mike, because we're not at NPE.
I know. It's you know, I tell people not being at NPE, it's a good news, bad news thing. You know, the bad part is that you don't get to see all the people, but the good news is you don't have all the logistic chaos of moving in, you know, piles of equipment and basically setting up factories, running them for a week and tearing them apart. So, you know, we get you kind of love the people part of it, but the rest of it is all hard work. So it's nice to be able to break it into pieces and do things at different places, at our place, at your place.
Yeah, it's a ton of work to do it live at NPE, but it is, you know, the camaraderie and the getting the whole industry together is certainly super exciting. So we're doing the next best thing. We're gonna have a live demonstration of our, well, exactly the same demonstration we were gonna do at NPE. We're gonna do it today. We've got our teams lined up and we're gonna record it, and we'll have an opportunity for some live interaction with the audience.
Yep, it's I like the demonstration. I mean, I have to compliment you guys on the tool design, because it's pretty interesting. You know, it takes an encyclopedia of bad mold design practices and puts it all in one, which allows you the ultimate demonstration of your technology, right? I mean, it's a family mold, so you got cavities, all different, you know, weights, part weights, and then you have thin runner sections, and then you have, you know, massive variations in wall thicknesses. So, I mean, it's really awful, right? But that's the beauty of it. It's so bad that it's a kind of an ingenious demonstration of your technology.
Yeah, I mean, we like to, we've really tried to design something that you know, don't try this with your normal process. This is something that showcases the kind of flexibility that Influx provides, but it's intentionally something you would certainly never want to try if you didn't have a process that could adapt in real time and overcome some of those molding challenges. So, Mike, Haitian is the largest machine manufacturer in the world.
Yes, they shipped last year in excess of 40,000 injection molding machines. So they're pretty with a pretty wide margin. They're the biggest producer, and they have a global presence. I mean, there isn't a single country on Earth that does injection molding where a Haitian machine doesn't exist.
Outstanding. And in markets, you guys are in pretty much every market.
Yeah, you know, from a machine configuration standpoint, we have the technology that allows us to play in all of the markets. You know, from consumer goods, medical, automotive. We have all electric, hybrid electric. We have two platen, servo hydraulic. The one constant with the entire product line is they're all extremely energy efficient. We have no conventional old school hydraulic machines. They really haven't been delivered in the product line for many years. So, you know, with our staffing plans and with our stocking plans for both machines and then spare components to be able to support the customer that operates 24/7, you know, with minimal downtime. So, you know, it's a big part of what we do. We got to help the customers, you know, by minimizing their pain and making it easy for them to push parts out the door.
Right. Well, that's what great companies do. You know, when faced with adversity, they find a way to overcome it, and you guys have done a great job of that. And you know, over the years, we've certainly shared, I guess, since 2017.
Since 2017.
Yeah.
You know, if you catch me on a bad day, I'll tell you it's since 27. But you know, that's okay.
Yeah. Well, we've shared a lot of customers. We've had a lot of good experiences, and it's been great to work with you guys. And looking forward to doing a lot more of that with our new partnership.
Absolutely, likewise. You know, this collaboration fits pretty nicely with the types of solutions that we like to provide to our customers and give them access to. It's technology that allows them to get into things that aren't necessarily restricted to proprietary processes. So, it's a solution that they can have available on our machines and on any machines. Our position in the market is focused really on expanding the portfolio of machines and technologies that we make available to all the partners and to all our customers. And when we look for partners, we're really looking for people that fit our our way of wanting to introduce technology to the customer base. And we like to be able to collaborate with people that have all kinds of customer orientation to their basic strategy. So Influx really meets that criteria. The technology is very interesting to us. We feel like it gives processing opportunities. It goes outside the box of conventional processing with utilizing the low and constant pressure platform that automatically recognizes changing conditions and adapts in real time. So specifically, the Influx platform we see simplifies process controls, particularly in certain areas such as using wide spec material, which is typical now when people are struggling to find resin. They're having to look at sustainable resins, more recycled materials, and those sorts of things. So Influx, what we really enjoy seeing in your demonstrations and in your applications are is a precise control of the melt flow front. And basically that gives us the ability to pack thin walls at lower speeds and pressures, certainly as compared to conventional processing techniques. So each of the points we feel is really highly complementary to the Haitian product line. And we just feel like Influx is a great solution that we want to make available to our customers.
So I think we're going to get out to the live demonstrations. We do have we have a chat function. So as you're watching the activities today online, we will have the plastics here. So Mercedes and Lindsay will be watching your questions come in through chat. They'll be then serving those questions up to our team for us to answer. And at this point, I think we can get out to the floor, and Brandon Birchmeyer, our Influx Director of Innovation, and Jason Holbrook, the Regional Sales Manager for Absolute Haitian, will take it from here.
Thank you, Gene, and thank you all for joining us. We wish we were doing this at NPE this year, and we hope we can congregate together in another 3 years. But today we're going to be doing this virtually. The traditional injection molding machine application relies very heavily on injection, speed, pack, and hold. Traditionally, molding practice limits the flexible process parameters where the machine doesn't consider the mold or the material. But with the Influx process, the machine is now controlled by the metrics of the mold and the material. Proprietary OEM technology can be a problem also, where it's not available for the other machines. Most molders utilize 2 or 3 different OEM machine suppliers. With the Influx technology, they can apply this to their entire machine fleet.
Yeah, and the benefits of control of pressure help maintain a more consistent flow front, minimize the amount of clamp pressure needed to mold the part, and reduces the molding stresses. Also, we're lowering the amount of shear heat induced during the injection phase, which results in faster cycles, less tonnage requirements, and reduced cooling time because of that shear heat being reduced.
The Haitian Jupiter 3 2-platen servo hydraulic machine provides a smaller footprint, more platen real estate for larger molds, and with the servo hydraulic system is more energy efficient, which is perfect for the Influx technology because traditionally machine size is driven by tonnage. But if we can reduce that tonnage requirement, still allowing for larger platen real estate, we're able to optimize your machine for your application. And one of the other challenges we have in today's plastic industry is the availability of sustainable resins. We have been challenged with these resin shortages all year, and it continues. One solution to this problem is to usher in post-consumer recycled resins. It's imperative that we do so for the global demand to reduce the plastics pollution. We must always reuse this material effectively.
Yeah, and you know, Jason, one of the most current and relevant issues in our industry today is how to deal with post-consumer regrind, or PCR. The technology Influx developed is one step towards solving this problem. We are providing an opportunity to use wider spec resins, especially as it pertains to viscosity variation. Our approach to utilizing sustainable resins today isn't really sustainable. We're trying to turn PCR into virgin equivalents, which makes them very expensive and limits availability. Our approach is, rather than asking the resin supplier to turn that recycle stream into a virgin equivalent, we're instead putting intelligence into the machine to adjust the process for the material. The reason we can do this is because the material is always controlling the machine. The Influx technology allows for that material to realize wide viscosity shifts without transferring that risk into the process. Viscosity shifts in your resin typically result in the need for process adjustments, forcing the operator to chase viscosity changes with processing changes. The Influx technology widens this window, allowing for fewer adjustments to the process. As material viscosity changes, our algorithms take over and adjust the process for you. We call this auto viscosity adjust, or AVA.
The demo you're about to see utilizes Haitian's Jupiter 3 5500, which is a 618-ton, 2-platen machine built with a high-performance mixing screw utilizing the latest cable control with the Influx system. The automation you will see, also provided by Absolute sister company, utilizes a high-electro 3-axis takeout robot depositing parts to a conveyor to a 5-axis Fingerprinting cobot to assemble the parts and stack them for distribution.
Yeah, and we'll be using our technology in a uniquely built Influx family mold, utilizing both a virgin resin and post-consumer regrind resin, both provided by Braskem. The Influx process will seamlessly transition between the two using the same process parameters. Now we're going to send it to the IEC, and a quick reminder to put your questions into our chat so we can get to those during our question and answer segment.
Hi, my name is Stacy Johnson. I'm a plastics engineer for Influx. I am here down on the Innovation and Education Center top floor at Influx headquarters, and we are running a family mold on a Haitian machine. Today I'm going to be showing you our auto viscosity adjust feature and how we react to blocking cavities. But first, I want to show you how we maneuver our screens and what each of our curves mean. So this is our Influx graph. This x-axis is our time. So you can see we are running for 2.5 seconds. So this pink line, that is our set point for our pressure. Our pressure is the nozzle transducer reading in the nozzle. And this green line is the actual reading from the nozzle. This velocity is, this purple line is our velocity. And this blue curve is our screw position. So you can see here, we are ramping up our pressure for half a second to 2,000 PSI, and then we're maintaining that pressure for another 2 seconds. So here are the actual readings for each curve. You can see here that we naturally profile our velocity to have our constant pressure. Here you can see right as we're trying to make it up to set point, our velocity spikes. That's because we're trying to pressurize our manifold. And then it starts to drop as it gets to set point and maintains. And then we see it increase it as our flow front increases. So here at half a second, these are the parts we made earlier. So you can get a play-by-play of what's going on in the tool during this process. So here is the half a second right when we start increasing our velocity some more. Then we kind of try to maintain our pressure until about this point when our lid fills. This is really where Influx starts to shine. Because when you run conventionally, once you fill your first part in an unbalanced runner, you're more than likely going to flash that part trying to fill out the rest. But Influx will see that, and you won't have to change anything, and it will just automatically adjust. It'll naturally profile your velocities so you don't flash it. You can see here, the velocity starts to slow down as it fills the other parts, the slowing as it finishes filling is actually going to pack the parts as it fills. So you don't need a hold phase when you're running Influx. So you're actually going to have a shorter cycle time. At the end, once we hit our pressure transducer, our cavity pressure transducer in the cavity, we actually react to that. We have something called a PFA, which is a multiplier, and we multiply that by our cavity pressure and subtract it from our set point. And so we are reacting to everything going on in the mold, and we're slowing down a little bit more, decreasing pressure, so we don't overpack our molds. So now that I showed you that, we're gonna block some parts. So when we're molding 4 parts, I grabbed a big bowl from our press. So basically this is gonna be our constant part that we measure throughout this entire demonstration. I'm gonna go ahead and I'm gonna start blocking cavities, but I'm not gonna block this bowl. So the first thing I am gonna block is our lid. So you should see it adjust. But while it's running, we'll go ahead and weigh this bowl. The bowl weighs 130 grams. You can see here that now that we block the lid, our pressure is remaining the same, but our velocity scaled down. This is what Influx does. It adjusts for that geometry in the mold. So it actually should have about the same weight. I'm going to go ahead and block these last 2 gates, so then we're only molding the bowl. And then we'll weigh this while it's running. So the bowl weighs 130 grams. So the weight is remaining fairly constant. This would not be possible with a conventional molded part. When you block a cavity conventionally, since you're running at that constant velocity for a set position, it's not going to see that change. It doesn't know what's going on completely in the mold. It's not going to adjust its velocity. So this is our last bowl. Moment of truth. It's 130 grams. So now I'm going to go ahead and I'm going to turn on all of the gates again, and we're going to run ABA. So we went ahead and we set up auto viscosity adjust. So what auto viscosity adjust does is it sees the change in viscosity and it adjusts the process to make good parts. So the first thing we do when we set up auto viscosity adjust is we set our melt travel. Our melt travel is our sprue travel, how far the machine pushes the sprue after we hit our set 0 point. Our set 0 point that we choose is the point where we know that the sprue is pressurized and that our check ring is set. So here we actually chose melt pressure to start melt travel at 2000 psi. So it's actually going to be about right here. We feel that we're going to get a good measurement every time for when to for our screw movement. So yeah, it's going to be right here. If you can see here, this is our travel. It's at 0, even though our screw is moving, until we hit about that point, about 0.1 seconds. So once we have set up our melt travel, we'll go ahead and we'll turn on our ABA. So our ABA is gonna, what we do is we pick a targeted melt travel and a target time. So we have a target melt travel of 3.9 and a target time of 1.25. So what we're trying to do is make it so every cycle our sprue travels 3.9 inches in 1.25 seconds, because that's what it's doing in our baseline process. So we put our target travel there. We put our target travel here and our 1.25 seconds here. You can see our travel is about 3.014 at about 0.974 seconds right now. If I move that cursor to 1.25, it should be about 3.9. So what Influx is going to do, and it's already doing it a little bit, is it's going to change its pressure. So once the viscosity changes, we're going from a 11 melt to a 35 melt. Yeah, right now, the material's already adjusting to the transition. We've introduced that regrind, but it still has quite a bit more of a transition to do. So it should get to about negative 25% difference. Now we'll just wait for the material to transition, and yeah.
What you making?
So right now we're running a family mold. We have 2 different size bowls, 4 different size spoons, and 1 large lid. We're really doing this to try and show off what Influx can do, because we're just so great with imbalanced molds.
That's a cool mold. Why'd you choose to put it in the Haitian?
We love working with the Haitian. They're really great to work with. We chose the Juniper 3 2-platen machine because it's wide platen real estate.
Yeah, it's a big mold.
Yeah, it is. And it's large array of applications, and it's low carbon footprint. Haitian is one of the largest molding manufacturers in the world. They make a lot. They have a large line of automation and machinery. We just
I expect that
really
from what
love
I've seen.
Haitian. Yeah,
I see a lot of Haitians out in the field.
you do. So I'll show you the robots now. So we are using an Absolute top entry linear robot along with a collaborative 6-axis Spanic robot. The reason it's collaborative is I can basically just stand here and it's not going to touch me. You don't need any safety gates with this robot. If I touch it, it would stop. So as you can see, we're almost fully transitioned. We're now running, we went from green to blue. So a blue regrind with a MFI of about 35 and from a green with an 11 MFI. And this is, I just thought it was a pretty transition color that we got earlier while it was transitioning from green to blue. So you can see here, this is the curve we were running earlier, the pressure curve. With our all green material, we were running at about 12,000 PSI. You can see it still says 12,000 PSI. But our AVA has adjusted 28%. And we have decreased our pressure about 28%. And we're still making really good parts. So we're still transitioning, but this is at about 30%. And you can see all our parts are still completely full. And we've maintained our screw position. And our velocity profile has almost remained completely the same. And that is really what makes Influx so great. It's what makes Influx a star above conventional molding, is that we can adjust to what's going on in the tool. The material and the tool are running the show. We're not doing anything. We're not changing that much. It's all in the tool. It's all in the material. And that's all for now, guys. Back to you.
It's been a great day here at Influx headquarters already. We've seen a really cool demonstration. You've already met Jason from Haitian and Brandon from the Influx team. We're welcoming Suji from Progressive Components and David from Bascom virtually. So welcome, guys. I'm Jody Hammock. I'm the Vice President of Talent and Customer Growth here at Influx, and I'm super excited to be here to ask a couple questions of the demonstration that we just saw. Let's start with you, David. What type of products were these recycled resins originally for?
Traditional recycled materials typically have a variation in them because there's multiple products that are used or that are collected and sourced and reprocessed together. For our material today, we're using the twine, and it is collected through a reverse logistics operation so that we're only getting twine. And because of that, the 3.5 to 5 melt flow that twine's always made out of, once it's reprocessed and black, it winds up being somewhere between about a 4.5 and a 6 melt flow.
Where would this material have ended up if it wasn't turned into PCR?
If we weren't recycling this material, it would undoubtedly wind up in a landfill. It's not something that would be able to be collected through traditional reclamation that Waste Management or somebody like that would do at a material recovery facility. So it would wind up being in a landfill if not for our operation here. Today, there's about 19 billion pounds a year produced of polypropylene in North America. And of that, only about 1 billion pounds is actually being recycled. And most of that is post-industrial reclaim coming from facilities that are manufacturing something and they have waste product that they can't use within their own system. And so that's sent outside and reprocessed and used for something else. And then a small percentage of the reprocessed material is post-consumer, and that is what this is. So collecting post-consumer is a very high priority for us, and we're going to be doing more of it. This is one of our initial projects.
If you weren't given the constraints of trying to replicate virgin resins, if the spec was now wide and you could go from 10 to 30 MFI, what impact would that have on the cost or availability?
A broader spec range would absolutely open up the ability to use more post-consumer reclaim. We're limited right now by having to target basically virgin quality material levels to be able to process it in different applications. So if you have the ability to use a broader range, you can use more material.
Tell me what makes the Braskem PCR unique.
The Braskem recycled material is a high quality. We have a lot of QC constraints that we put on everything. We do a lot of testing and we make sure that the material is exactly what the customer has specified before it goes out the door. We have a lot of commitments that are for 2030 and 2025. We're going to build our way up to very large quantities of recycled resin. Worldwide, we're going to be over 2 billion pounds of recycled content materials. So we're going to have some good quality material so our customers will be able to use it.
What are the unique things your customers are trying to solve that Influx will help with?
An analogy for that is gasoline. So if you look at plastic as you have to have very tight specifications, gasoline, if you have a car that can use 87 octane, you can basically use anything. If you have a car that requires 92 or 93 octane and above, then you're very limited in what you can put in your car. So same concept, if you can use a 10 to a 30 melt flow, as opposed to a 10 to a 15 melt flow, you've broadened up the level of material you can use.
And Jason, so tell me a little bit more about the Jupiter 3 machine.
The two-platen technology has been around for many years, but what has popularized its application is the smaller footprint while also getting the larger platen real estate. As mold designs have become more complex by the use of cores and valve gates and hot runner systems, the size of the molds have increased in relation to the part size. The two-platen design allows for more flexibility and us to adjust to the higher mold size to part ratio.
Which is something we want our customers to take advantage of, right? We want to use the decreased pressure and decreased tonnage requirements from the Influx process. To date, most molders will size their injection molding machines based on the tonnage requirements required, and will typically use most, if not all, of the tonnage the machine has to mold their parts. However, with the low constant pressure approach, that machine tonnage no longer is necessarily your constraint. Now you can look at things like platen size and maximizing your cavitation in your tool to help you determine what injection molding machine you should purchase and or what options you should configure it for.
Jason, are there other values of the 2-platen machine that their customers are interested in?
Yes, the introduction of the servo motor controlled pump systems significantly reduced the amount of power required to operate the machine. And coupled with the 2-platen design, the power to machine size ratio has been reduced dramatically. And when developing a machine specification, you want to consider the machine in 2 different halves, the clamp and the injection side. And the 2-platen design allows more flexibility to tailor to the customer's applications.
Gosh, we met at the K-Show several years ago, and we were really excited to further our partnership with Haitian. How do you think that this partnership is going to impact the industry?
You know, with our earlier collaboration on the all-electric machine in 2017, we've since realized that moving into our hydraulic line would hit a much larger market share. And we expect the largest impact to be with those customers molding with wide-spec resins. People that are molding containers, housewares, horticultural, and running in machines that are 500 ton and larger. But we also see a lot of applications where we can reduce the stress, we can reduce the tonnage, cycle times. They could also be achieved using the Influx technology and applies across all machine lines.
Exciting. It seems like Haitian's a full-service provider. How's that benefited?
Well, we want to work with the best, and we want to work with a supplier that can support a complete turnkey system that includes the machine and the automation. Absolute Haitian can support this with a full range of molding machines and automation, utilizing the most current and relevant technologies. And the Jupiter 3 platform is a very favorable choice because of the range in machine sizes, the smaller footprint, and the energy savings you get through the servo hydraulic configuration. And it fits a wide range of applications that a lot of our customers and Haitian's customers have a lot of demand for.
Besides the machine and the Influx technology, we're also showcasing other technologies and great partners today. One of those is progressive component system cooling. Suji, what is system cooling and why is it so important?
When you look at a typical molding process, 60% of that process is cooling. When we look at process monitoring systems that are available on the market, they're typically monitoring speeds, pressures, temperatures, but not the cooling that's occurring within the mold. With such a large percentage of the cycle being cooling, there's a lot of information and insight that can be gained by better understanding what's happening inside the mold. System cooling uses sensors mounted within the manifold to measure these metrics and provide valuable data of what's occurring within the mold.
How does system cooling differ from standard manifolds and other flow meters?
Standard water manifolds simply direct water from a single source, such as a thermolator or a chiller, into the circuits of the mold. Most flow meters have a mechanical device that helps detect what that flow is, but aren't multi-purpose devices or data collection devices. With system cooling, you have sealed electronic sensors that are integrated into every outleg of the circuit, measuring flow and temperature. That, coupled with an inlet temperature sensor, allow you to see flow and temperature deltas for each individual circuit. The data is shown in real time and stored, so you can use it to identify historical trends and target your maintenance as your mold continues to run.
What are some of the key benefits of system cooling?
There are several benefits to system cooling. Increased productivity by being able to optimize your cooling throughout your mold and reduce cycle time. Being able to detect changes in water flow that might affect part quality rather than waiting for a defect to show itself in the actual parts. Being able to identify overall trends in your water flow and temperature throughout the mold allow you to detect things as scale buildup, blockages, or any sort of reduced flow through your mold that would affect your overall cycle times. Another key benefit is the ability to enter line sizes in conjunction with all of the other data that's being collected. It'll calculate a Reynolds number and show you if you're achieving turbulent flow through every circuit of your mold and maximizing your cooling efficiency. Having all of this data allows you to optimize your process, your part quality, and have a complete understanding of your mold cooling status. System cooling is a comprehensive water monitoring system for understanding and optimizing your overall process.
You know, Sujay, it feels like we have the same approach to advancing Industry 4.0. It's so important to have relevant data, especially if you're going to build intelligence into a system. No machine can learn without data. The approach from Influx technology and system cooling technology and Haitian's VNC technology is putting all that data into the hands of the customer so they can make intelligent decisions themselves. And ultimately, then the true goal of Influx is to have the machine make those intelligent decisions for you down the road.
You know, much of Industry 4.0 centralizes on bringing all of that information to one location. And this is why we want to partner with companies like Influx and Progressive Components and bring that information to the machine in real time.
All really cool things happening. Tell me, Brandon, what is so significant about our 7-cavity Influx built mold?
Well, we never take it easy on ourselves. We wanted to make a challenging mold. And the reason we did this tool specifically was because how impossible it is to make with the conventional molding approach. The reason is if I use a rheology-based injection speed and I continue to inject all these parts, I'm going to flash this lid out as I try to continue to fill out the other bowls. And that's because the molding machine doesn't really know any better. It's just trying to put the plastic in the tool at the same rate. As you do that, the pressure in the system continues to increase, and unfortunately we have a catastrophic event and we'll flash that lid out. So you really can't mold these parts in this tool with the conventional approach. However, with the low constant pressure approach, now we're adapting in real time to what's happening in the mold. Which Stacy did a wonderful job of explaining is, as we fill out this lid, we actually start slowing down our velocity in the screw as we continue to fill out the other cavities. We're adapting in real time to the conditions of the mold. Something unique to the low constant pressure approach. And now that imbalance or balance is not so critical to a successful molding product. With low constant pressure, you're able to really be a lot more creative and adapt your process to your needs and your products. You know, in the words of Justin Timberlake, we're bringing family molds back. Now we're going to send them to the mold shop.
Hello, everybody. My name is Dan Lumpkin, and I'm here today to talk to you a little bit about Influx's Mold Building and Innovation Center. Influx is changing the way the world molds, but we're also changing the way molds are designed and built using the art and science of innovation as our fundamental principles. First and foremost, Influx is a world-class mold builder based here in Hamilton, Ohio, which is just north of Cincinnati. As most of you already know, we are a wholly owned subsidiary of Procter & Gamble, but in the context of mold builds, Procter & Gamble is also a customer, while we also serve many different industries in the world. Since we are a new shop on the block, we have that new car smell with a lot of new equipment, a lot of the latest, greatest technologies across a wide range of machining capabilities. Surface grinding, turning, wire EDM, sinker EDM, high-speed machining, as well as one of the largest automated lines in North America today that allows us to run a 24/7 lights-out operation. Our team is built on diversity. We have purposely built a unique collection of talent from a wide range of industries. Some of our folks come from the traditional mold building industry itself, while others come from automotive. We've even got folks from SpaceX and coin minting here. And the intent was to build a team that would challenge conventional thinking and challenge the way that molds are built today and bring fresh eyes and new ideas to an industry that has really been doing things the same way for decades.
Hi everybody, I'm Brent Hawk. I lead our mold design and project management teams here at Influx. I'm going to walk you through our typical process that we go through on all of our projects. We review every new project for its ability to use the Influx technology. Influx technology can help with cycle time, up-cavitating, reducing capital needs. It can bring a lot of value to our customer and save them both on their per piece price and on their original capital investment. At Influx, we use Siemens NX to design the molds. We use it to machine the molds out in the shop as well. But we'll have a couple experienced mold designers on your project throughout the process. Our project management team will walk you through the entire project or the entire experience. We are a paperless shop. As I mentioned, in NX, we do not really make part prints for our shop. We put notes and we put color coding in our models. So our models contain all the necessary information for our shop to make that component. This makes it easy to manage engineering changes out on the shop floor. It makes it easy for us to communicate. Makes it easier for us to communicate to our machinists.
Mold building is a science at Influx, not an art. Speed, precision, reliability, interchangeability, communication, and collaboration are at the core of who we are as a mold builder. We live and thrive in a world that is based upon complete customization, all while delivering new engineering principles to our customer. We have to have an organization, a technology, and a suite of equipment that enables us to deliver these critical customer needs. People are at the core of our customer experience. Every mold build starts with a thorough fabrication strategy development. Our team of manufacturing engineers review every mold component, and in tandem with our production control and scheduling team, they define the ideal and most cost-efficient method of machining them. This allows us to understand the full capabilities of our shop, and when appropriate, leverage our network of suppliers and partners. Our shop is outfitted with some of the newest and most mold-capable CNC equipment in the industry. We partner with brands like Makino, OKK, Doosan, Perco, and Okamoto, to name a few. The highlight of our operation is our fully automated machining center. This automated line allows us to push numerous work pieces through multiple machining and inspection operations with little to no operator touches or setups. That gives us, and in the end you, advantages in speed, lights out manufacturing, and best-in-class repeatability. Our customers should expect to receive a comprehensive review of their mold, steel certifications, and watch our mold makers give their final stamp of approval before it goes into action.
At Influx, the quality mindset is a critical component of our day-to-day functions. We strive to deliver what we promise and to achieve excellence in every action. Our quality management system allows us to provide consistent and reliable results to our global customer base. Our cutting-edge metrology lab is equipped with high-precision equipment to ensure we are meeting our customer specifications and targets. At Influx, your quality needs become our quality needs.
As mentioned earlier, we are excited to have the Plastics here with us. Mercedes and Lindsay, they have a weekly podcast with lots of followers, and they call themselves the Voices of Resin. They're an inspiration to the industry, and we're excited to have them here. Welcome to Influx.
Hey, thanks.
Hey, we're an inspiration to the industry.
Oh, that's what my mom tells me too.
Yeah. So I'm Mercedes Landazuri.
I'm Lindsay Nebel.
And with our powers combined, we are Plastics, the Voices of Resin. And we were almost in unison that time.
We're getting better.
So close. So I am Color Lab Technology Director at Peacock Colors in the Chicago area. And I'm Counselor for Color and Appearance Division of Society of Plastics Engineers and current Chair of Recycling Division.
A lot of things. I am the Vice President of Membership Engagement on the Executive Board for the Society of Plastics Engineers, and I also am on the Injection Molding Board, and then I am also a plastics engineer at Tech Tank in Erie, Pennsylvania.
So if you couldn't tell, we met through an online dating app called Society of Plastics Engineers.
Yes, great app. It's great to meet a lot of people.
So we met through planning a women's networking event through SPE. I
didn't say no. We planned it. It was great.
Yes. So we so we quickly became best friends in the industry.
Nemesis.
Well, nemesis. We're always competing, and we decided we should start a podcast so we can hang out more.
Yeah.
So you can check us out anywhere you listen to your podcasts. Plastics. We're also on social media. Follow us. We like to talk to people about plastics.
And we just like to talk. So.
Yeah. And the thing that struck me when I met Lindsay on a conference call was she was different. She sounded different from everybody else. She was her real, authentic self. And part of the reason that we started the podcast was to show that people like us exist and our plastics engineers. If we can get camera 2 to zoom in on Lindsay's hairpin here,
so we dress appropriately in all occasions. So just so you know.
So yeah, we wanted to foster diversity, much like your team here is built on diversity of thought, diversity of faces, and diversity of voices.
Yeah.
That's us.
That's us.
Thanks for having us.
So Jason, I hear you have some pretty sweet takeaways about what we've seen this morning. So what have you got for us?
Well, you got to see the video of the Haitian Jupiter 3 two-platen machine, and the idea of coupling with the Influx technology is the ability to reduce the tonnage while still having the larger platen real estate and being able to couple that with the proper shot size on the molding machine. And it's a seamless partnership. Influx brings one of the most current and relevant technologies to the industry, and we're excited to develop this with you guys.
Yeah, and another key takeaway from today is the sustainable resin piece, right? It's such an important part to the industry as a whole. It's a focus, whether you're talking about the automotive sector or consumer packaging, it's a focus for everyone, right? We want to use more sustainable resins, and it's a goal a lot of us want to achieve. The problem is I don't know that our approach has always been sustainable. We're trying to turn these recycled resins into virgin equivalents, which adds costs and also limits supply. We've kind of approached this completely differently. Like, we want to build intelligence into the machine so that material viscosity variation doesn't show up as variation in your finished product. We want that variation to be taken care of by the machine itself and the intelligence that we built into it.
I mean, I do love a good smart machine, as long as they don't take over. So if you register for samples, watch your mailbox. Well, probably a little too big for your mailbox, but watch your FedEx. Or
Depends on the size of your mailbox.
Well, that's true. And if you didn't and you want some, comment in the chat. We'll hook you up, unless we've stolen all the samples.
We took a lot of samples yesterday when we were on tour.
Right,
we pretty much, I think we had to do some, Brandon had to do some dumpster diving this morning because we took all the good ones. But
and after the Q&A, we will see you back here for a chat with Jean, the Influx CTO, who's going to share our journey from to autonomous molding.
And when we do take the quick break here, you can go visit the Expo Center, visit the virtual booths. They're pretty fun.
And keep putting your questions in the chat.
So feel free to tell. Yeah, you just said that. Keep putting your questions in the chat. So what options need to be added to a machine to properly operate with the Influx package?
Well, today, adding the Influx interface to the machine, certainly. But we also are using a proportional valve on the machine. And then with the Influx package, there is an extra nozzle that has the pressure transducer in it that needs to be added to the machine. It's rather easy. It fits right into your standard 1 3/4 8 nozzle. But further developments might even be that we can eliminate the proportional valve, which will be a much easier transition into new machines and retrofitting of older machines.
Well, the question I have, so if I run my molding machine pressure limited or strictly in the hold phase, can I achieve the same results? Can I cheat around this and just ignore you guys?
Typical Lindsay. Typical Lindsay.
I gotta go to the shortcut.
Sure. Common question, right? So there's two big reasons why it doesn't really work in your normal machine setup. First and foremost is true plastic pressure, right? We use a sensor installed in the nozzle to measure that. It's not a proxy based off of hydraulic oil, which we know is probably a bad intensification ratio. Is not a great method of predicting plastic pressure. Using a Newtonian fluid to predict non-Newtonian, not great. We teach it anyway. I don't know how I feel about that. Also, even a load cell, better, but still not there. We want the sensitivity of the actual plastic as it's entering the mold. So we want true plastic pressure. 2 is tuning. Your machine isn't built to do what Influx is trying to do with it. It has universal tuning parameters to mold your conventional way. Those are parameters typically unavailable to a normal operator, right? You're not able to change the tuning of the machine. With the Influx process, we actually want you to be able to tune the process to the mold. So one of the things we offer is the ability to tune your process, your PID tuning controls, to maintain the pressure control to set point as you would want. And those would be tuning parameters specific to the Influx system versus the conventional system. If you're running pressure limited in your conventional molding machine, it's not great control. You're going to keep bouncing off of that top pressure if you don't alarm out. I would not recommend running a machine like that. They're just not built to run that way.
Well, I mean, it would make it more exciting.
Absolutely, if you like to see machines.
Brandon, you and I were having a conversation the other day about the difference in older machines, the PV closed loop, pressure and velocity closed loop, and how that affects the Influx process versus not necessarily needing it. And I'd like you to explain that a little bit more to us.
Yeah, so we're always molding from the plastics perspective, and that's the key component here. I'm sure you've heard that term before, but we don't want to rely on the molding machine as much anymore, especially things like where your screw is and whatnot. We all know a machine doing the exact same thing every time does not give me the exact same part. If it did, this industry would be so much easier, right? It'd be a lot easier on all of us, but that's just not the case. A machine being 100% repeatable does not result in the same exact part every time. That's why we need to build the intelligence in. And we do that by always measuring the plastic. And you saw in the demonstration that Stacy gave, the mold and material are always in control. And that's the big difference here. Your molding machines of today don't care what's between the platens. It just doesn't care. It only cares about the parameters you enter into the controller. With Influx, now the mold and material play an important and dramatic role in how that whole process is conveyed. As you saw when we switched the resins, that pressure automatically modulates based on the resin. The resin and the mold are always providing that feedback. So when we think about like closed loop control, this is, I'm going to ramble a little bit here, but we talk about, 20, 30 years ago, we talked about closed loop control on injection molding machines and what that meant. And it's really just, is the machine going the velocity you told it to do, right? It still isn't tying it back to the material or the mold. And we think we've actually closed the loop on the part. What do we care most about? We care most about the plastic part. We don't care most about the machine being repeatable. We want a repeatable part. So let's measure it. Let's always measure the plastic, and that's what we're doing. Our process is always driven by the material and always driven by the mold, not by the press.
So you close that loop between the material and the mold.
Exactly.
Where not necessarily the machine needed to do that any longer.
Correct.
And that's so dramatically different. It reminds me, I was at an event a few years ago, and there was an architect giving the keynote speech and talking about how architects look at a material and ask, how does this material want to be used? And so I just wrote that down now. It's like, it's this new way to respect the material. It's the boss, right? As Stacy said, the material and the mold, they're the boss.
And it's amazing how well it can figure it out. You saw in our obviously crazy 7-cavity family tool, we have mini runner samples that people may have solved before with very small runner systems. Now the geometry dictates velocity, 1-to-1 ratio. Like, I don't have to tell that machine how fast to go or how slow to go. The plastic will figure it out based on the pressure it generates. So those changes in nominal wall thicknesses or going through a living hinge or drastic geometry changes or even gate alternatives. Now you get like things like gating from thick to thin. I don't have to play by those rules anymore. So lots more flexibility in part design, gate location, and look at the family tool, right? How often do you see family molds in the industry anymore?
Right.
Like hardly ever. Yeah. Why? Because you're told you can't do it.
Right.
We are kind of rewriting the rules because we think you should have that flexibility, and the way you get it is by letting the mold and the material dictate the process.
With this rebellious streak, do you guys have leather jackets? If so, where do I get one?
I should say this isn't always easy. We have personally, and a lot of us here have a lot of mentors in the industry and a lot of respect. And it's not always easy to go against the grain. But I think that's why our tagline is fearless innovation.
Yeah.
We have to be a little bit fearless, a little bit cocky maybe in our approach. But we have a lot of confidence in what we do and what we can provide. And we love that we're partnering with someone like Haitian, a huge player in the industry. And as the OEMs come on board, it just validates what we think we can bring to the table. And we want to work with, more OEMs, more material partners in the industry so everyone can take advantage of this. And I think you're starting to see hopefully a new revolution of innovation in injection molding. Because it's been kind of stagnant, to be honest, for the last 20 years.
Absolutely. It reminds me of the example that I always use is the ketchup bottle, right? It was the same for, you think of a bottle and you think of it like that, right? But it was just wild how much innovation happens when you flip it on its head, right?
Sure.
And that's scary, right?
Absolutely.
But I have a T-shirt I should have worn that says "Your comfort zone will kill you." Right? You speak to the stagnation. It's if you keep doing the same thing that you've always done,
Sure.
You're going to keep getting the same thing you've always gotten. I'm really excited about this technology. So, what features on a machine should be discussed in further details when considering the use of Influx technology?
Well, this is a general question. This should be considered whenever talking about a molding machine, but even more so when you're talking about Influx, you should consider the screw geometry. We've got different general purpose screws, we've got barrier screws, we've got hybrid barrier screws, and you can really tailor the screw and the whole injection unit to the type of material that you're going to be running. And then certainly picking which screw is the right screw for you, an A or B or a C screw, depending on the pressure that is provided to you with each one of those screws. If you've got a particular job that you're running with Influx and it's a more of a thin wall application, you might want to go with an A screw to get over that 30,000 PSI plastic pressure.
So I gotta ask, does Influx only work on certain types of resins? Because I'm pretty sure I have a Gaylord of some Polypro with some metal sweepings in it and probably whatever else was on the floor that
Yeah,
day.
well,
can I run that?
metal shavings are still going to be bad. We recommend magnets if you can to get that out. But the resin itself, we've been pretty successful along a wide range of resins, whether it's polyolefins like your polypropylenes, polyethylenes that the packaging industry is used to. We've had a lot of success on ABS, PC-ABS, especially in the automotive realm, and then polycarbonates, nylon, glass-filled materials, up to I think we've done up to like 60% long glass fibers. PEEK, you name it. I'm sure there's something out there that we haven't touched, but
I'll find it.
as far as like the general range, we're very comfortable and we've had great success across the board.
And you've been able to transition between many different materials.
Yeah. Actually, one of the things we like to show off, this is a different trial we do, but in this instance, you saw us going from two different polypros, virgin to a post-consumer regrind. We would do another demonstration. This was actually at the Fakuma show back in 2018 or 19. We would go from polypropylene to ABS in real time. Same idea. So completely different polymer families, right? Making the same part because we're recognizing the change in the material viscosity and adjusting the process appropriately.
That would make my life so much easier. And in a color house where you're switching resins all the time.
I can't think of a time it would make my life more difficult.
Yeah. So we got a question from the chat here. If the process has a slower fill time and the tool is a cold sprue and runner system, will I experience gate freeze?
It's a good question. So there's always a minimum pressure, right? I think you saw in the example that Stacy did for the one material we had 12,000 PSI set in. If we were trying to run that at 3,000 PSI, that exactly what happened, right? It's not enough pressure, my screw's going to hesitate. What we want to do is make sure we have enough efficient pressure so that we never get that hesitation in the screw. One thing you'll never see in an influx process is something like screw bounce that happens at transfer. We don't transfer. We don't want to transfer. We think that isn't healthy for the process. I don't want erratic movements in my screw or my material, especially near the end of fill. That's why you get that nice slowdown in velocity. That's what we're looking for in our process. It's more repeatable, it's better for the machine, and it's less impactful to things like party line. And think about what it does to like your check ring and everything else in the system when you have a dramatic transfer from high pressure to low pressure.
So where does Haitian expect the Influx technology will be most widely utilized in the market?
Right now, it's probably going to be in the machine sizes that are over 500 tons, and certainly with molders that are running the wide spec resins. But in saying that, there's a lot of applications out there, even in the medical, in thin wall, where you have a really tight tolerance for your injection process, where this is going to be very beneficial too.
Let's see that.
So we've got another question from the chat here. Does Influx require sensors in the mold?
No, we don't. In today's example, you saw that we had a sensor in this tool to showcase that we can use it and we will react to it via our PFA technology. But it's not a requirement. In fact, Stacy did a good job of explaining melt travel during the demonstration. And that's our proxy for creating a virtual cavity pressure if we need to. The neat thing with melt travel is it takes away all the error that happens during your check ring seating, during those first initial movements of the screw. So what we're always doing is getting the screw 0 point based on plastic pressure. Because we're downstream of all that craziness, we actually will, in the specific example Stacy did, at 2,000 PSI plastic pressure, I zero my screw. Now I'm going to look at screw travel from that point forward. So that actually helps you with things like density variation. Now I'm always at the same compressibility point of the material before I start looking at the resin as it moves. So we call it melt travel. It's how far the melt has traveled once it's pressurized, rather than just direct screw travel, right? We're, again, using the material to dictate what's going on in the mold. And then we would use that melt travel to create a virtual cavity pressure that we would then respond to. So not a requirement. We can work with cavity pressure sensors, but it's not a must-have.
Another question from the chat. Can the pressure transducers on the injection cylinder be calibrated for Influx?
Well, it depends. So on a hydraulic system, I would say no. Again, day one of plastics, of your first plastics class, you probably learned plastics non-Newtonian. A couple of days later, you're taught this is hydraulic pressure, and you're going to use that to predict plastic pressure. Probably not great, right? You shouldn't use a Newtonian material to predict a non-Newtonian material, but it's prevalent in the industry. During hold phase, when everything's static, it's actually pretty close, but what it's telling you during fill is completely off. It doesn't know any better. I should say, though, that load cells have dramatically improved that on an electric machine, and we hope someday to get to the point where we can use sensors on the machine. It's just the technology's just not there yet. We want that true plastic pressure and the sensitivity it gives us.
So another question from the chat is, does Influx System work on both hydraulic and electric machines, or do I have to pick and choose?
It works on both of them, and we've developed it on both. In fact, we started with the electric machine. Out here on the floor since 2017, we'd have an all-electric machine running the Influx technology. Certainly on the hydraulic platform, it's probably going to be a little bit more beneficial because we can go up in the tonnage range and hit certain market shares where they use servo-hydraulic machines and where they're running that wide-spec material that I mentioned earlier to you, but we do it on both now.
So what's the oldest machine that you guys have set up?
1978 Sandretto.
Ooh, that sounds like a fancy car.
I can't say I've ever. Yeah,
Vintage.
it sounds more like a car. Were you on an injection molding machine?
Yep.
Okay.
It wasn't a car.
It wasn't a car. Fine. All right. Fair enough. So is the mold data stored in the Influx control? I
got this one, Liz.
I appreciate it.
Is the mold data stored in the Influx control, the machine control, or both? Comma.
There we go.
In between the,
I didn't breathe. Sorry.
Yeah, it shows up in both. So Influx will house a lot of data about the Influx process, right? You know, what my melt pressure was, things like that, everything you saw in that graph. But at the same time, the high-10 machine is going to give you all the things you're used to seeing, like your peak injection pressures and your barrel temps and your recovery settings and all that, right? We are only controlling that fill portion. The molding machine is still doing everything else in the process.
You know, and as this, just to elaborate on the answer to that, as we develop this relationship, we're probably going to have a VNC of the Influx to the molding machine control where the entire mold setup can be captured on the molding machine's HMI. Not quite there yet, but we're getting really close.
And it's fun to have partners in, like, you know, progressive components with system cooling, because you can start to envision, like, what is this going to look like in the future?
You can pull all that information into it as well.
Exactly. Having all that at your fingerprints, at your fingertips from the machine standpoint, like what system cooling can give you, what Influx can give you, is going to make you so powerful as a molder. And that's, you can start to see how Industry 4.0 is heading in that direction. It's going to have all that data at your fingertips to make intelligent decisions yourself, and then eventually have the machine make those intelligent decisions for you.
Don't worry, I'll find a way to abuse the data.
It's so exciting though. It's like Industrial Revolution 4.0.
Yeah.
Wasn't 4.0 used? So let's go like 4.0.
No, but Industrial Revolution
All right.
4.0.
All right, I'll go with
right?
it.
Like hashtag, if we can just hashtag it. Okay, another question from the chat. Can you use gas assist with the Influx system?
Yes. No. And it works really well, actually. We have some really good examples of that. One of them is, you might be familiar with the P&G Swiffer product. That's
Heard of it? Yes,
has some
intimately.
gas assist. So some of the things we find in gas assist is we will have normally what we call our typically in injection molding, right? You skin your process, and you have a very thin layer that initially touches the mold surface as you're flowing down the channel of the mold.
Ours is heartbreak.
Yep. Ours is thicker. We have a little bit thicker because we're not flowing as fast velocity-wise. So that frozen fraction is a bit thicker with Influx. What happens because of that is we get further gas penetration into our part without blow through. So if you want to have gas get further penetrate your part, you're going to get that with the Influx process without that gas blowing through those thicker sections. Also, we naturally lightweight the part by eliminating the hold phase. You're going to usually eliminate hold phase anyway in gas assist. You'd be surprised how much better the internals look. It's a very smooth finish, both inside and out of the part with the gas assist being utilized. But there's many examples where we've used gas assist and done it successfully.
I want to see it cut through. I love a good cut through.
We have some of those, so remind me later. I'll show you some.
Later. How does the Influx adaptable process differ than others in the market, such as Angle's IQ weight control or Craftsman-Fi's APC Plus?
Yeah, so I'll take this one again. The philosophy is still the same. So let's talk about dependent versus independent factors. And this is for all you golfers out there. Dependent factors are, if you got a 20-foot putt, you got to get two things right to make that putt. You got to get the direction you're aiming, and you got to get your pace. That's why it's so hard.
And your beer, yeah.
How much have you drank?
We're still in the cart. We're watching all this. Yeah.
But that's why it's hard, right? You got to get your direction and your pace right, and both of those dictate where the ball goes. That's very similar in the conventional molding process. If I change my transfer position, do I need to adjust my injection velocity to meet my fill time? Maybe, maybe not. Do I need to adjust my hold pressure to compensate for the change I made in my transfer position? All these things are tied together. They're very dependent on one another. Mm-hmm. In fact, if you try to explore, just think about it. You're molding fast, rheology-based injection, so you're going to go fast, up to 95% full, 95% full. There isn't a window there. You've already put yourself in a corner about where you can explore in your process. You're already on the edge of catastrophe. I can add.
Where we live.
Where we live there.
Yeah.
We live there.
But think about that. I can go and break any injection molding process almost out there by adding a little bit to shot size. Mm-hmm. That's how fragile the industry is. You can't do that to an influx process. You add shot size, it'll compensate automatically. These are the things that we got to build into the system. I forgot what my point was going to be. What was the question again?
We were busy
they
golfing.
keep changing. Oh yes, golfing. I'm sorry. So, but what's neat about pressure and time in our process is those factors are dependent of each other. I don't have the illustration here, but we do a process called LECR where we find the optimal pressure and time settings, and we build a window. And the reason we build a window is so that I can operate my time and pressure independent of each other in this window. That is, make those factors independent. So I can change pressure and time without changing something else to compensate, like you typically find in your conventional process where everything's tied so closely together. So that's one of the big benefits we bring to you.
I do love to break a good process, so I suppose that would be helpful.
So we got another question from the chat for Jason.
Ooh, specific.
Hey,
that's you.
Thank you.
Is it possible to reduce the tonnage on a machine for a mold using Influx?
Absolutely. That's one of the big selling features and why we're interested in it. With the Influx process, because you're molding with a lower pressure, you don't need the tonnage as resistance to that injection pressure. Therefore, you can drop the tonnage requirement. And with the two-platen technology that we were using, that was part of the showcase for today, is to show you that we can still get the large platen real estate, but we may be able to drop the tonnage requirement. And if you're dropping tonnage requirements, you're dropping energy consumption, you're dropping your overall piece price.
Mm-hmm. What if I'm reckless and want the higher tonnage for bragging rights? Can I?
You may do it.
Thank you.
Yes, and I'll sell you a bigger machine to do it.
I like it. So how do you determine the pressure required for the initial material? Do you just wing it?
We have a process. I need to start carrying around a whiteboard with me. So what we do is we build a process window. We call this LECR. That's just fancy term for largest empty corner rectangle. And what we do is we will build a polygon. So we look for the relationship between pressure and time. First thing we do is, what's the absolute lowest pressure I can fill this part at? Let's take this for example. Maybe I can fill that out at that green material at 10,000 psi. But it takes me 5 seconds to do it. So that would be my low pressure, low time point. And then I start walking that pressure up, 11,000, 12,000, 13,000, 14,000, and the time to fill gets less and less, unsurprisingly. Then at each one of those pressure segments, we add time until, similar to gate seal, I can't put weight into the part anymore, or I create some other defect. And what you get is an interesting looking trapezoidal polygon thing. All largest empty corner rectangle does is find the largest rectangle in the polygon. Just does some fancy math. The center of that rectangle is the most robust spot to run your part. It is not going to make you the best part, but it's the most robust. It's the farthest away from all the edges of that polygon where something bad happened. So that's how we determine your initial pressure and time, and then we would build a DOE from that.
It's taking us away from the edge of catastrophe.
Yes.
I don't know how I feel about that.
Yes. It's catastrophe, tooling engineers don't get along, so we're here for the tooling engineers.
All right.
So another question from the chat here. What is the technology that enables you to determine viscosity on the fly in the nozzle?
So great question. This is one of my favorite things to answer. So
You look really excited.
Yeah.
He's
rubbing his hands.
So let's talk about rheometers for a minute and how we determine MFI material, right? How's that done? Too bad the Braskem folks aren't here. They can explain it a lot better than I can.
Come on, Braskem, we showed up.
Make them answer.
But when you determine the MFI of your material, that's done with constant pressure. Like, that's how that test is done. It's not done with constant velocity. That's how we categorize our resin, is with constant pressure. So when you mold with constant pressure, you're effectively turning your barrel into a rheometer in a way. Those fill time differences are directly a result of viscosity if I'm operating at the same exact pressure. My fill time changes because at the same pressure, I know the viscosity shifted. So that's what we're doing. We're modulating that pressure for those viscosity shifts in real time. That's what's cool, is we're measuring the material the same way it's determined before it ever hits the machine.
I was going to say, you're kind of utilizing your data sheet a little bit more efficiently than...
And what cool information, right? We talk about Industry 4.0. Think about how valuable this data could be for the material supplier, right? I am running PCR. How much variation are you guys seeing? Now I have a direct variable I can tie back and saying, this week I saw 20% variation. Last month, though, it was down to 5% variation. What's changed? But again, Industry 4.0, now we can make this data available to that material supplier in a more real-time fashion, and the partnerships become much, much tighter. The data becomes more and more relevant, and this is how we build intelligent systems.
So we can go apples to apples instead of those darn oranges.
Yeah.
It's kind of like cruise control on a car. You set your speed at 65, and if you see resistance to your force, your cruise control kicks in. If you're going downhill, it backs off. It does it all automatically for you.
Yeah, exactly. And then, you throw some nasty regrind in, and now you got your lane assist, right?
Yeah, that's what I was going to say, lane assist.
Go around those corners, or slowing down because you're approaching someone else. So exactly, it's that advancement. And just like, I like the automotive industry correlation, because the sensors, right? How do cars become self-driving? They have tons of sensors. They have to know everything that's around them. That's kind of what we're doing here, right? We have to, at the very least, measure the thing you're molding all the time. Yeah. That's the beauty of melt pressure and why we control at it. Don't wait to, and the best conventional process up to this point has been using a cavity sensor to let you know when to transfer. But that's very binary, right? There's still an area of unknown, and you're still relying on that machine to do a repeatable thing to provide a repeatable product. If it was that easy, we wouldn't be here.
Right.
Yeah, it's so forward thinking. I mean, you think about the plants, the factories of the future, and there's we're really envisioning a lot of automation taking hold, and that can't happen without this kind of technology. Well, it could, but it's a lot easier with this kind of technology in place.
Absolutely. Yeah, we want people to use regrind and not pass that liability on. Right. Like, that's how you fix this problem, right? Like, this is how we use more recycled resin. And just like anything that we've dealt with as as humans, innovation's the answer. Like, we can innovate our way out of this, and I have full confidence. This is not the only approach, but another approach on how to utilize more of this resin in your normal everyday products.
Well, I think the Braskem guy had said earlier, it's kind of like the octane in a fuel. If you make an engine that can run a lower octane and you can save money on your resin and use a wider spec of fuel supply, why wouldn't you?
Exactly.
Right.
And think about the flexibility you now put in your supply chain, right? I hope another hurricane doesn't hit Houston, but it could happen. And look what that does to the industry, right? It has a snowball effect through everyone.
Literally, for the snow.
And building all that flexibility in your supply chain now makes you, those acts of God don't, hinder your production so much.
Right. Makes sense.
Another question from the chat: what is the biggest difference between Influx and Angle IQ? Can you explain more?
So just the philosophy is number one. So Angle IQ, it's still the general philosophy, right, of a rheology-based injection velocity to a transfer and a hold pressure, and the juggling of those parameters as they relate to each other, right, which isn't easy, like we talked about the golfing and the dependent factors. With Influx, we're using the low constant pressure approach, always from the plastics perspective. The Angle IQ, Crossmify's APC Plus, they don't measure plastic pressure. They might have a proxy for plastic pressure, but it's not as good as the real thing, I can promise you that. And they're not utilizing it to drive the process all the time. They're still using machine-centric controls to predict what the plastic may or may not do. I'm trying to eliminate all the machine parts because I only care about what the plastic part and mold are making. You know, for example, we talk about cushion, for example. A repeatable cushion means repeatable plastic parts. I disagree. Again, you're relying on a machine to do the same thing over and over, and you expect that to translate into a good part. I can make you two dramatically different parts with the same exact cushion.
I could probably do that too.
You show off. You guys are all show offs over here.
You come see me, I'll get you some parts. So, the hypothetical story here. Say I accidentally order a blow mold or extrusion grade resin instead of my injection molding resin. What happens? Do I get fired?
Well, believe it or not, we can actually, we have examples where we use blow molded grades in injection molding. One is for toothbrushes. We actually went from an engineering grade PET to a blow molding grade PET. Prior attempts to that caused too much residual stress in the handles, and they would break. Last thing you want is a broken toothbrush in a jail, for example.
Well, how aggressive are you brushing your teeth is the first question.
But going to the blow mold grade, we don't have as much of the residual stress in the part because we're operating at lower pressures, and they would not break as easily. So we're able to, it's actually quite a big cost save being able to go to a blow mold general purpose grade versus engineering grade PET.
I keep my job.
What polymer was used in the demo?
Polypropylene. Polypropylene virgin and a polypropylene-based PCR.
So how does Influx work for multi-cavity PET preforms?
We've only dabbled a little bit in PET preforms. I would say we're more of a general purpose solution at this point in time. As PET preform molding it's like its own entity, right? We call it injection molding, but it's like its own special injection molding. We are working in that area to, one, learn more about it, become better at it, and understand how we can apply our technology better. We haven't done a ton, but it's something we're looking into more.
So what you're saying is you've just not dedicated your time and you really just need to buckle down. Because I've seen you slacking off around
Well,
here.
I need to get a PET machine out here, so.
I guess that feels
I need a
fair.
preform press to do some work on that, probably.
So in regards to running PCR, regrind, or other more sustainable resins, is there anything a processor needs to consider when developing their process if they can anticipate large fluctuations in the resins?
Yeah, well, I would say the easiest way to go about this is running with Influx, because then you'd recognize that variation in real time and react to it. But without Influx, if I had to deal with it, I would definitely measure your resin as much as you possibly can, especially if you're worried about what's incoming. The data is so important, so if you don't have a rheometer on site, I recommend getting them. It used to be very prevalent in the industry. Everyone would always check their resin, right? I feel like we got a little bit spoiled in the last few years with our resin has become so good and so repeatable, no one has to bother testing it anymore. But we kind of need to take a different approach, right? We want to use more sustainable resin streams. Probably a good idea to do some incoming inspection and things like that if you're going down that route.
Right. I mean, there are all these new resins being developed, biocomposites and things like that, where even from lot to lot, they vary. It's giving me some headaches.
Right. But that's where we would love to work with those material suppliers to understand, why do your customers, why is this variation hurting them? And we think we can help. And that's why we want to partner with as many folks in the industry as possible to, I think you can maybe think about how you develop and create PCR and PIR and utilize it. We just got to think differently.
Why don't we clarify with the audience the difference between PCR and PIR? All these acronyms confuse people.
Yeah, PCR, post-consumer regrind, PIR, post-industrial regrind. Industrial is better controlled. It's kind of like the waste that someone couldn't reuse but will then sell. Consumer is the stuff that you got to sort through. It's less controlled.
Yeah. Thank you.
It's funny, as you know, I work in the color business, and when you're working with PCR, The consumer stuff, you really see the trends, like the color shift. Like after October, you start to see a lot more oranges and stuff like that.
Do not want pumpkin spice latte color.
Hey, like listen, I know you're basic.
I want my basic color.
Okay,
all
we got
year
a few
round.
months
Thank
to
you very
go
much.
for pumpkin spice.
All right, fair enough.
So will the Influx system change a mold's cooling requirements?
Not necessarily. And so one of the nice things is, you can take your mold you have today and utilize Influx. You don't have to change your tool to utilize it. But why we build molds here and we have an entire mold shop is to take advantage of some of the benefits we're providing. What's neat about cooling, and if you think about conformal cooling, and a lot's been happening in conformal cooling, additive manufacturing. One of the problems is the high pressures that the system's under, right? How close do you get those cooling channels to the steel surface, things like that? Well, you utilize a low pressure process approach and you can get away with a lot more. You can put those cooling lines closer to the steel because I'm not operating at 30,000 PSI, I'm operating at 15,000 PSI. So you can get more creative and maybe take more risks in that cooling channel setup than you would traditionally because you would be worried about the extreme pressures that mold would be experiencing.
And I want to comment on that. In some of the thin wall stuff where you would typically use injection velocity to reach a shear point so that you had the proper heat to fill some of those thin areas, with the Influx technology and using more of a pressure approach, you wouldn't necessarily get all that shear heat, therefore not introducing those BTUs to the mold, therefore not having to pull those BTs out during the cooling phase.
Exactly.
Right? So I think in some cases it may affect the cooling of the mold and in a good way dropping the cycle because you're not having to pull as many temps out of the tool.
Yep, you're absolutely right.
Listen, I'm all about getting away with stuff and taking risks. So, so our very last question: Haitian is known for its cost and robust equipment. What else you got for us?
Well, we are the largest machine manufacturer in the world. We produced over 42,000 molding machines last year. We are also, with the Absolute Group, a full automation house. So we have our own line of top entry linear robots. We do custom automation. We're a FNUC integrator. In fact, the system that you saw today was provided by the Absolute Group of companies, who is the representative of Haitian. Haitian is a full line supplier. They build from 40-ton machines all the way up to 6,000-ton machines. So basically any application you want to get into, whether it's conventional molding, automotive molding, medical molding, packaging, we've got machine applications for each one of them.
Got us covered.
So just to quick wrap up with the Q&A, if we didn't get to yours, we're going to be continuing to answer in the chat.
Not ignoring you.
Yeah, not ignoring you. We care about you very much. Also, mark your calendars for the second edition of the Influx Fearless Innovation Series on July 20th.
Ooh. So we're going to take a 15-minute break, do what you got to do, maybe get some snacks. That's my hobby. Then we're going to come back here to the stage where Gene, the Influx CTO, will be sharing what's next on our journey to autonomous molding. And during the break, besides snack getting, do not forget to visit the Expo Center. The partner booths are opportunities to engage live with team members, and the booths will be open until 5 Eastern.
So at Influx, our innovation pipeline is all about the journey to autonomous molding. It's about making it easier for a process engineer to run their operation, to operate their presses. It's about the machinery making intelligent decisions on behalf of the operator. And so over the past several years, I've been working against an innovation portfolio that's included a lot of things. And I'm going to touch on each one of these as we go through the presentation. But there have been a number of innovations that we'll talk about. And then I want to talk about where we're headed, because we've got a number of innovations that are in the pipeline that take this journey really to the first phases of what we would think of as true autonomous operating machinery and operating processes. And so, over the past several years, we've introduced a lot of innovation. We've introduced auto-tuning. So this is software that allows you to very easily tune your machine to be optimal for the part, the mold, the material, the machine, all those things that are the create the environment you're running in, the machine is tuned to match those needs. Second thing that we've done is brought what we call our auto viscosity innovation, auto viscosity adjust. And what auto viscosity adjust allows you to do is really run massive changes in material viscosity, things that just are really not possible with a conventional type process. Why is this important? It's important because it helps your operation run more smoothly as batch-to-batch variations and other things occur. It can help provide some flexibility in terms of the kinds of materials that you can run. And then for sustainability, and we'll talk a little bit more about that as we go through the presentation, this is a technology that addresses a need that is simply not really met elsewhere from other technologies in the industry, which is to be able to take materials that can vary vastly in their viscosity and even shot to shot very significantly, and be able to adapt to those changes in real time without the need for an operator there babysitting that press and trying to keep it running. It's going to make those adjustments on behalf of the operator. So another thing that we've brought to our customers is something we call Smart Start, and we're Smart Start 1.0. And this is something, you can think of a battery case, and for anybody who's ever molded a battery case container, very tall, slender cores, very difficult to get your flow front to wrap around the top of those cores and stay even as it comes down the sides of the cores. This is something that during startup can be very, very fragile, finicky kinds of startups. And so being able to have a system that allows the process engineer to script the first several shots to be able to start that system up easily, whether you've been down for 5 minutes or been down for 10 minutes or starting the mold up after it's been out of the press for a while. This is a critical feature that helps on those kinds of molds, which again, it avoids damage to the mold, it avoids downtime, it avoids the need to bring a super skilled process engineer out there to start it up every time it goes down. So very, very advantageous for a lot of applications. Modeling, this is something that's been a bit of a journey for us. We've had the capability to model the influx process for several years. But what we've done more recently is we've created standardized approaches both in Autodesk and also in Mold-X 3D that allow us to not just analyze and create mold flow results on our own, but also we can train our customers how to do this. We can partner with Autodesk and with Mold-X 3D and others to be able to bring this kind of technology and knowledge to their user bases. And it's created a great capability for us to to be able to design parts and confidently know that you're going to get the kinds of advantages that we typically bring to a given application. You can now model those in advance to build your confidence that you're going to see those advantages. So process fingerprinting, this is just kind of an inherent thing with Influx, and we've brought some tools to make this easier, but process fingerprinting, our process in essence is a fingerprint. It's a pressure profile. And so when I create this pressure profile for a given mold or a given part type, I can then replicate that. I can take a tool and transfer it from press 1 to press 2, replicate that pressure profile, make the same part. I can create that pressure profile in a single cavity tool or a 4-cavity tool and then scale it to a 16 or a 24 or 32 cavity tool. So this is a very very powerful tool that our technology lends itself to, and we do this a lot with our customers. Rethinking molds. So we're working with lower pressures. We need less tonnage. We don't hesitate when we flow. All these things create opportunities in how you design and fabricate an injection mold. And so as a company, we have injection molding capabilities. We build a fairly significant number of molds. But the reason we're in the mold building business is twofold. One, it's so that we can develop the design standards and understanding of how this technology works when you're designing a part and constructing a mold. But also that we can work with others. We can work with the rest of the industry to help other mold builders understand how to get the most out of the technology. And so we've got the level of expertise necessary to do it. But very impactful, up-cavitating tools, running at faster cycle times, running in smaller presses. These are all things that are big advantages in an Influx design tool. So Smart Start 2.0. So we talked about Smart Start 1.0. Smart Start 2.0 is really slick because the way it works is for any process, I have a velocity profile that matches what that part needs. That's the optimal velocity profile for that part. In this case, it's a flip-top closure. And once I understand this optimal velocity profile, I can then use that in my algorithms. I can make this the dominant thing in my algorithms during my startup mode. So, for the first 3 shots or the first 5 shots, this becomes the dominant factor in my algorithm. I recreate that in all of those early shots, and I make parts that aren't short, aren't flashed, aren't creating the kind of issues that can cause downtime and cause, scrap and other things in your process. So again, this is in the innovation pipeline, so it's coming, but very powerful because it's simple to set up. You enable it, once you've got this curve, you enable it and you're good to go. So then we have something called quick process. And with quick process, what we're doing, we're basically giving the process engineer a very easy way to get to a starting point that they can begin to develop a process. The system works by first determining there's a first test shot. That first test shot determines what's the minimum pressure and time needed to fill that tool, okay? And once I've determined that, I have a second learning shot. So I've got learning shot number 1, learning shot number 2. What does learning shot number 2 do? It defines where that processing window is. And so it gives me a starting point where I can then move on to step number 3, which is basically begin to develop your process. So you may have a very involved steps that you do. You may have a very elaborate DOE and other things that you do to set up your processes. Or you may have a very simple approach. You may say, hey, I'm in the center of my process window. I'm going to, do, a few different directions off that process. And I'm going to, create some good parts and I'm going to submit them for metrology. I mean, there's very different approaches based on the types of parts that people are running. But the key is I'm getting you started in three strokes, three injection cycles. Auto process development. So the key thing to know about auto process development in the context of Influx, with conventional processing, you have highly complex interactions that occur between your variables. So, here in this case, we're looking at transfer position and injection velocity, and here we're measuring, flash. If the part flashes, that's a problem. And what you can see is the interaction between these two variables is causing a lot of change in the part, okay? With Influx, we're comparing step pressure with PFA pressure. So, 2 different knobs, but we also have 3 knobs that we turn in our process. Here's 2 of them, PFA and step pressure. Still looking at flash. You can see we never get close to flashing. So, why is this important? It's because we have a much less complex relationship between the variables that are, that define our process. And because these variables and their interactions are so much simpler, you can then envision automating this process much more easily. And so when we think about process development, again, we think about this minimum pressure and time to fill the mold, but then we establish an entire window. In our process, our press itself now can create this and determine what our optimal process window is. So, here I've gone a little bit further than just kind of getting you into, kind of a sweet spot to develop your own process window. I'm going to define for you what your process window is, and we can even take that a step further and actually help you or walk you through a DOE to develop the optimal process at that point. So major simplification for a process engineer. Data flux. The importance of data flux. Data flux is forming the building blocks for what ultimately becomes autonomous. And so, in its simplest form, it's a data acquisition system. But what's really slick about this is I'm able to, in real time, create what I'll call novel processing parameters. So things that I can maybe calculate offline today, I can measure and calculate and create in real time using this kind of a process. So I'm capturing the data, I can do analysis and correlation with the data that I'm capturing. I can create these control parameters that are really not creatable in other ways, and I'm forming, again, the building blocks for my machine learning autonomous future. And so finally, the future, autonomous 2.0. And so, where we're headed is we're going to take all that information that we're able to create in data flux, and we can create machine learning algorithms. And we're doing this today. We don't have it in our product that's out there broadly in the market, but we have this in our labs. And so we're able to, create learning algorithms. We're able to use those novel processing parameters that we can create from that data. We're then able to translate that into real-time intelligent control and unleash innovation. So super powerful stuff. Again, it's a journey, and this is kind of out there a little bit towards the end of the journey that we've been talking about here today. But great progress against this, and super excited about the future that this holds. And thank you.